Hello students, we are starting a topic alternating current or alternating voltage. So what is alternating current? Alternating current is that current whose magnitude is continuously changing and direction is changing periodically. Okay, let me show it graphically. This axis we choose time axis, okay, and this axis we choose current axis. Then alternating current starts from, if I say in terms of magnitude, then it starts from 0, it becomes maximum 0, 1, 2, 3, 4, 5, it becomes maximum 5. Again it starts decreasing from 5, it becomes 5, 4, 3, 2, 1, 0 again minus 1, minus 2, minus 3, minus 4, minus 5 becomes maximum in the negative side, and again minus 4, minus 3, minus 2, minus 1, minus 1, and 0. Finally it comes back to 0. So this is how again it starts from 0 to 5, again 5 to 0, again 0 to minus 5, and minus 5 to 0. So this way alternating current changes its magnitude continuously from 0 to 5 in the positive side, again from 5 to 0 in the positive side only, again it goes to the negative side. Okay, that way it goes. Let me show it graphically. This side we have chosen x-axis as t and y-axis as I. Then it is said that alternate current starts from 0, okay, it becomes 1, 2, 3, 4, and it attains the maximum value. Okay, again it comes back to 0, this is 0. Okay, again it goes to the negative sign, it becomes maximum, and negative side again starts going towards 0, and finally it comes to 0. So this way it keeps on repeating itself. Okay, so alternating current here, what's happening, the magnitude is continuously changing. It is 0 initially, then it becomes 1, 2, 3, 4. Let's say the maximum value is 5. Okay, it becomes 1, 2, 3, 4, and it becomes maximum 5. Again it starts decreasing, 4, 3, 2, 1, again 0. Again it goes to the negative side. Okay, let's say the peak value of this current is, in this case it has to be minus 5, it is plus 5, it has to be minus 5. So it becomes minus 1, minus 2, minus 3, minus 4, and minus 5. Again it starts decreasing and becomes minus 4, minus 3, minus 2, minus 1, and 0. So this way it keeps on repeating itself. So here this kind of motion, this kind of current, we call it alternating current. Here what's happening, here the magnitude is continuously changing and the direction is changing periodically. It becomes positive, again it becomes negative, again it becomes positive, again it becomes negative. So here direction is changing periodically, which was different than the current which we have studied before. We studied direct current. In the direct current, what happens, it doesn't change its direction, it doesn't become negative, okay, and the current is constant. If it is 2 ampere, then it becomes 2 ampere. Okay, so that's the difference between the alternate current and direct current. Now this is a sine wave, so we can represent this current, alternating current, in terms of a function, mathematical function, which is given by this I0 sine 2 pi ft. So what is f is the frequency over here. So we know that this is the time period, capital T, this is capital T, time period, no, and this is the amplitude. Okay, in this case amplitude we have chosen I0, this is I0, this amplitude is I0. So this can be written as I0 sine 2 pi ft. Okay, 2 pi f, where f is the function, t is the t-axis. So this function, depending upon different value of f, or you can see capital, depending on different value of f or t, okay, depending upon different value of this t, f is constant. Okay, f is what, f is 1 by t, no. So it can be, for this wave, if I choose t is 1 second, okay, then time period is 1 second, then f will be 1 hertz, 1 by t is 1 hertz. So f will be constant, but for different value of t, for t equals to 0.5 second, here it is again becoming 0. Okay, that we can easily find out with this sine function. For t t equals to t by 2, t equals to t by 2, and f equals to 1 by t, it is becoming sine pi. No, let me check. I equals to I0. I'm finding what is t equals to, what is the value of this current when t equals to t by 2 at this point. From the graph it is 0. Whether this function obeys this graph or not, okay, whether this function follows this graph or not, we have to check it. We want to check it. I'm just checking it for one point. Okay, so sine and 2 pi f we can be written as 1 by t, in place of t we have to write at t at this point t is t half. No, so we write t by 2. How much we got sine pi, which is 0. That means this function completely defines this wave. Okay, so this is why the alternating current is always represented by the sinusoidal wave. Okay, sinusoidal function. Similarly, voltage can also be represented by b0 sine 2 pi ft, or we can write b0 sine, this 2 pi f is equals to omega t. Okay, in this case also we can write I0 sine omega t. Here omega is angular frequency. It's called angular frequency. Okay, so b equals to b0 sine omega t. This is the representation of alternating voltage, mathematical representation of alternating voltage, and this is also the mathematical representation of alternate current. Okay, in terms of 2 pi f or omega, what is you can write here. The v0 is the maximum voltage, so we call it peak voltage. Omega is the angular frequency. T is the time. For different time we'll find the voltage at an instant. For t equals to t by 4, so this is t0, this is t by 4, this is t by 2. Okay, this is t by 4 and this is t. So for t equals to t by 4 also we can find the voltage. That voltage would be this voltage, peak voltage. Okay, for different value of t we can easily find this value of voltage. This voltage is the instantaneous voltage. Okay, for any instant you can find the value of this voltage using this function, okay, which will follow the graph.